Okay, so welcome in everyone. Today is day one of us doing the Blind 75 this year. It starts real easy. Actually, a good handful of you guys have already done this problem. This is the very first Blind 75 problem, which if you don't know, you can get there by going to neetcode.io and then hitting this practice button right here. And you've got a selection of a few different problem sets. We're just doing the Blind 75 this year. If you stick around for next year, we'll do the NeetCode 150 as well. And you can see there's a bunch of different topics here, and if you expand one of the topics, you can see we're starting with arrays and hashing, which we'll talk about what that means in a sec. We get this list, and we're literally just going to go down through it. So yeah, if you're following along with these problems, this is a great one-stop access for all the problems we'll be doing. The problem links in the text threads also have links to LeetCode problems. So if you prefer to solve the problem on LeetCode, you can do that through those links. If anybody cares about this, LeetCode, NeetCode does not live update with LeetCode. Sorry, this is we're gonna talk more about NeetCode later. It doesn't live update, and occasionally LeetCode will update problems, or some of those problems are premium, so you can't access them there, or they'll add test cases and things like that that are not present on this site. So at times you might actually want to go to LeetCode, but we'll be here for today. And yeah, so we'll give you a little taste for the format on these sessions, and we'll just basically keep doing them the way we're doing today. So let's take a look at the problem, shall we? Well, I guess any questions about the general format before we launch into it here? If you do have questions, please throw them in chat. I do have chat pulled up, so I can read those. Sweet, okay. My name's B, by the way. That's a little picture of me in the corner of my iPad. Yeah. Okay, so our problem today is called contains duplicate. We'll read through it. We'll do a little bit of diagramming just to think about how it works, and we'll code through a couple solutions, and then I got a brief presentation for you guys. Okay, so contains duplicate. It says given an integer array nums, we want to return true if any value appears more than once in the array, and otherwise we will return false. So, for example here, we've got this nums array that is 1, 2, 3, 3, and we return true because we got this duplicate element. 3 appears twice, or at least twice is what I should say. So we return true because there was, in fact, a duplicate. Second example here, our nums array is 1, 2, 3, 4. It's all unique elements. Nothing occurs twice or more, so we return false because there were no duplicates. So obviously very simple test cases here. I don't think we have much diagramming to do on the solution there. We won't take a look at the hints because I'm just going to explain those to you guys, but let's take a look and think about how we could solve this. We'll go over a couple of different methods just to cover our bases. Okay, so let's take an example array. Let's say we've got, this one that did have a duplicate. The question is, how can we programmatically determine whether or not there is a duplicate, right? What we'll call the naive method, which is generally what you would be doing by hand if you had a really long data set and you had to do it manually, you had to do it with a paper and pen. What we might do is we might look at each number. So we'll start with 1, for example, and I'll actually use an arrow to indicate that's the one we're looking at right now. And we can compare it against the following elements in the array and see if we ever have a match. So for example, we might start by looking at 1 and comparing it to 2. Obviously, those are not the same element, so we'll compare the number to 3, not the same element, compare it to 3, not the same element, and so we've confirmed by this point that 1 does not repeat itself later on in the array, right? We'll go through this in more of a pseudocode or a practical way, and then we'll talk about how this translates to code. So now that we've confirmed that 1 does not show up anywhere else in the array, we can move on to 2. And we'll basically do the same thing. Notice by the time we're looking at 2 as our comparative element, we don't need to compare it backwards anymore because we've already done that comparison, right? 1 has already been compared against 2. We know it's not the same element. So we'll start here. We'll say 2. Is that the same as 3? No, it's not. Is that the same as 3? No, it's not. Okay, so now we are done checking if 2 has any duplicates later on. We get here, and obviously, well, hopefully obviously, we take a look at these 2 elements and we say, oh, those are actually the same. This means we do have a duplicate, and in terms of the problem, this is when we would return true, or our conclusion would be that there is a duplicate somewhere in the array. I'm not going to rehash that for the unique elements example, but let's say we got to this point. and we knew that, or we realized, these are still distinct elements. We haven't found any duplicates yet. The time that this would end and we would return true is when we get to this point, and there's nothing else to look at. So obviously 4 at this point can't have any duplicates that come after it, and that's how that we know that we're done. So yeah, that's kind of the by hand method. Hopefully that is like pretty intuitive, because that, I don't know, it doesn't get much simpler than that. The problem is that's a little bit slow, right? Imagine, if this array suddenly has, what is that? If this array suddenly has 1,000,000 elements, you've got to make 1,000,000 comparisons, and then 999,999 comparisons, and then 999,998 comparisons, and so on and so forth until you get down to the very last element, potentially. So that takes a really, really long time, and it's something that we would like to avoid. Let's actually start, though, by coding up the naive approach, and then we'll talk about how we can improve it a little bit. Yeah. Okay, so in terms of the approach that we just looked at, here's how we can write that up in code. For starters, we had that white arrow that represented a pointer that said, hey, let's look through, or we've got to do something for every element in the array. When we've got to do something like that, we can say something like for well, and this is, I've mentioned this a few times already, but we're doing these problems in Python. So we could say something like for I in range len nums. And so what this is going to do is it's going to give us the indexes of all the elements in the array. So if there's 10 elements, we'll start with 0, and then we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So for each of those elements, what we're going to want to do is we're going to want to start at the next element. So we could say something like for j in range, and I'll talk about what this means in just a sec, I plus 1 out to len nums. Okay, so what this inner part is saying is go ahead and compare it, for starters, against the next element, right? So if we're looking at index 2, this inner part, or this j loop, is going to start at index 3 and go forward from there. Okay, so what I and j represent here are the indexes of 2 elements that we're comparing. What we could say is, okay, let's say that the element at index I is the same as the element at index j. Okay, if this happens, we know we actually have found a duplicate, right? That means we can return true. Okay, and like we said earlier, if we get through the entire array, we've compared every element against every following element, and we never found any duplicates. So by the time we get out of this for loop here, we can now return false and say, hey, we never found any duplicates. That means that we're good to go. We know there's no duplicates, we can return false. Let's go ahead and run this, because I probably messed something up. I know it's like, okay, so just FYI, as we do these, the run button here gives us just a couple test cases to make sure that we've got, normal, or we don't have any weird errors going on. And then the submit button is going to test us against all of the possible test cases, and you can see we've got an acceptable answer here. Like we talked about, it's a little bit slow, so what can we do to improve this? Well, there's lots of things we can do. Let's talk about 2 other approaches we could take. Well, actually, any questions on the naive method so far? Or we'll move on from it, but any questions on the naive method? Oh, or comments, for that matter? If you think I'm terrible at this, I would love to hear that in more constructive terms. Oh, a few people are typing. Okay. I'm gonna let y'all type your questions or comments. I'll comment this out for now. Oh, how do you do comments in Python again? Is it the 3 quotes? Great. So I'll keep this up there. If you have any questions, please feel free to drop them in the chat. The code will still be here, but I'm going to keep going and talk about some other methods that we can use to solve this problem. There's actually a couple I can think of. I want to keep it short for today. Okay, let's talk about The topic, actually. So if you recall, when we opened this up, the topic we were looking at was arrays and hashing. Hopefully you know what an array is by this point in your computer science career. It's just effectively a list of numbers, and for Python it literally is a list of numbers. What do we mean by hashing? So we won't go too much into the details of what hashing is, but in short, hashing allows us to make collections of things that are uniquely identified. That was a really esoteric way of saying it lets us figure out and prevent duplication of items. The two primary data structures that we'll talk about that have to do with hashing are hash sets and hash maps, which in Python we call dictionaries. And so here's how it works basically is we can say, so similar logic, and then we'll actually improve upon this as well. We'll say here's what I'll say is for num in nums. So earlier we had what we call a range-based for loop. This went through the size, or it used the indexes. So we went through each index in the size of the array. This is what we might call a for each loop. And this means I don't really care about the indexes, just give me the elements themselves. So go through each element is what this is effectively saying. And here's what we'll do. Well, and we'll talk about another way we can do this in just a sec. We're going to put them into a hash set. And this is, again, just a way of storing data that ensures that we don't have duplicates. If we encounter a duplicate, it does not get added in, is how you can think of it. It's a little bit more complex than that, but we'll leave it like that. So how do you initialize a set in Python? We can say something like scene, which is just going to be the name of our hash set, and then we just produce a set here. Okay, so now we're going to go through, again, each number in the nums array, and we're going to go ahead and add it to scene. Okay, and what this does is, if it's not there yet, it gets added in. And if it's in there already, we just ignore it. Wow, actually there's so many ways that we can do this. We're going to cover a couple different approaches here. So we'll start with this one. So what this gets us by the time we're done is a hash set that has all of the numbers in the array without duplicates, right? Let me think. Actually, I think this is the second approach we want to take. So let's actually step back for a sec. Earlier I was saying, hey, if we try to add in an element that we've already added in, it just won't get added in. We actually have terminology or syntax that allows us to figure out if that situation has happened. So here's what that looks like. We can say something like if num, the thing that we're looking at, is in scene. So if we've already seen this element before, we can return false. Okay, and if we haven't seen it before, we'll go ahead and add it in and continue on to the next number, right? Oh, sorry, not return false. This is going to be return true because we've seen a duplicate. Okay, and if we get all the way through and we never saw any duplicates, just like before, we can return false. Okay, and we'll talk about even more things that we can improve here. So let's just take a moment to pause here. How is this improved from our previous solution? Well, first of all, let's run it to confirm it actually works, because I'd be messing stuff up. And it worked. Okay, great. So how is this an improvement from our... I forgot that's what my iPad wallpaper background was. How is this an improvement from our previous... Yes. Mince has helpfully put in the chat, big O. Earlier I was saying, hey, one of the weaknesses of going through each of the elements sequentially and having to look at all the following elements is it's a lot of comparisons, right? So how is the set approach an improvement on that? In short, sets allow us to figure out if we've already seen an element very quickly. Again, we won't dig too much in the details of how that works. You can think of it for now as it sort of being a superpower of sets. You can ask it, hey, have we seen this element before? And it can tell you basically immediately, or what we might say is O of 1 complexity, constant time complexity, whether or not we have seen it, right? Adding an element to the set also is that quick. So sets are very, very helpful for us when we need to figure out if there have been duplicates or which elements we've seen so far. or if we just need to quickly identify if we have or have not seen an element. Okay, so this is much quicker, and what it eliminates essentially is us having to do the red arrow. So instead, this way, we look at this element, and we've got, I'll just signify it as like a circle here. Oh, that's not a circle. I mean, not that sets have a specific shape, but I want it to be a circle. Okay, we can look at this element and say, have we seen it before? Here's our set over here. And obviously there's nothing in there, so we can immediately say, no, we have not seen this element before. Once we realize we haven't seen it before, we go ahead and put it in. And notice we don't have to do the comparison against all of the other elements, right? We just get to do that, it's very quick, and we move on to the next element. And we do the same thing. We say, have we seen 2 in the set before, or is it in the set already? No, it's not, so that means we can add it in and move on to the next element. And again, we get to forego the potentially million, comparisons we've got from here on out. And this is where the primary improvement comes from, is us not having to search through the set as we go. Oh, it's not, hold on. Oh, I thought it was 9:41 a.m. right now. Why does my iPad say 9:41 a.m.? I have to be quicker than this. Okay, we're going to go through one more solution here. It's actually just a slight improvement on the thing that we just looked at, which is to say what we can do, and this is maybe not really an improvement, this is just a different way of approaching it. What we can do is we can say, and this I think was the first solution that got posted today, we'll improve this also slightly. We can say, let's go ahead and make a set from the array. And this is actually something you can do in Python. You can take one data structure, throw it into a set, and it'll do basically this chunk right here for us, or at least the production part of it. We can construct the set, and this will be all the same numbers without any duplicates. And then what we can say is something along these lines. If the length of no dupes, so the number of elements in the set, is the same as the number of elements in the list, that means nothing was deduplicated, and that means there were no duplicates, so we can return false. Okay, and otherwise we can go ahead and return true. Okay, so if we threw it into a set, got rid of all the duplicates, and we still had the same number of elements, that means nothing was deduplicated, there were no duplicates, and, well, that's the problem that we're trying to figure out, right? Now, if the number of elements differs, that means we got rid of some elements because they were duplicates, and that would confirm to us, again, that there were duplicates, we return true. But we can rework this even a little bit more. We can say, hey, actually, this whole no dupes thing, we can just produce that set, get the length of that set, and then compare it against the length of nums, not nuns, but nums. And this itself actually is going to produce a Boolean value for us. This is either true or it's false. We can return this. Now, here's what's a little bit funky here. If the two lengths are the same, we want to return false. So what we can do is we can say, actually, tell me if the lengths are not the same. If they're not the same, then there were duplicates. That's this chunk right here. And if they were the same, that means there were no duplicates. We can return false. That's effectively this block right here. Okay. Let me just space this a little bit. And then we will quickly jump into that presentation because we're running out of time. Let's just confirm this works, though. I, again, love to mess tiny things up, but it worked, thank God. And yeah, so a few different ways for us to solve that problem. Here's one weakness of this approach as opposed to our for loop approach, is that in the one-liner approach here, we produce the entire set. We're going to go through every single element regardless of if we would have found a duplicate early or not. So this is very simple, short, sweet, and to the point. One benefit of this approach right here is that if we're partway through producing that set and we realize, oh, I've actually seen this element already, we get to be done immediately. We don't have to go through the rest of the data, which, if there's a million elements and the first two are duplicates, we want to stop really early, right? So the early exit is a benefit of this approach right here, whereas this one is just a little easier to write. Okay. Questions? Comments? Can someone do it in fewer commands than this? Or functions? I would love to know. Or, and this is actually something I mentioned, I would love to see you guys' it is January 9th on my iPad. I would love to see you guys' like really wacky approaches to this problem, because I would love to, like, it's so easy and simple. I would love to see like the weirdest possible solution to this. Okay, let's jump over. In the absence of questions, it seems like no questions. But it has been stuck at 9:41 a.m. This whole time. I'm gonna go ahead and stop this screen share and throw a different screen share up. So give me 1 sec. Let's see if it'll let me do this. Okay, are you guys... man, are you guys... oh man, it's doing the thing again. Please, stream work. Why is it doing that? We're a level 3 boosted server. This should not be happening. Man, okay, let me try it one more time. This guy? Me? Oh, it's not 9:41 a.m. My iPad's being weird because I didn't use it all summer. I wonder what you know what's weird though is I used it during summer. So like, and I was in Washington. The stream is still not working, guys. I apologize. Sometimes technology is like this. We're gonna be done before, I was gonna say 9:30, before 10 a.m. We're gonna be done hopefully before 7:30, by the way. Most of these sessions should be about half an hour long. Please, stream work. Tomorrow is their IRL meeting. No, there is not. We are still working on getting... there's like a long process for getting physical meeting spaces reserved for new clubs, so we will not be having our first in-person meeting till... currently we're playing on 9/23, September 23rd, but I don't even know if that's going to happen. Okay, the stream is not working, so let me try it one last time, and if it really just doesn't work, then we'll see, I guess. Yeah, actually, well, I mean, can my board members give this a shot? There is a day 1 presentation in the Google Drive if someone wants to try that out. Yeah, this is life sometimes, guys. Well, if it doesn't work, thanks for tuning in, you guys. Who's taking 329 with Jared? Not me. No, it's not working for me either. Man. Well, that's life sometimes. We'll try it at a different meeting, perhaps. Yeah, no stream. Oh, and now it's not even like... well, the presentation was just about some various pieces of interview information that I thought would be helpful for you guys. We may go over it at a different meeting, because technology sometimes just, like, does not want to work. And that's like... oh my god, it's working! It's working! Can you guys see it? Yippee! We'll do these Discord meetings Monday through Thursday at 7 p.m. We are going to have some in-person meetings in the future. Again, we're still working on that. So, and there's no pressure to attend these. We would love to see you. I would love to teach you. I would love to answer your questions. But, you know, come as often as you can. The more the better, really, but whatever works for you. Okay, let's go through this. Let's go through this presentation. I apologize, I'm keeping you guys a couple minutes later, probably. Some interview tips and tricks, and also other resources. I've got this in a different window now, so if you say something in chat, I probably won't see it for the next, like, couple minutes. Let me see if I can open this on my phone, actually. I'm a little worried that if I click this, it's gonna kick me out. Oh no, I can't. Okay, great, I can see everything. Yes, we'll go over the problems 7 p.m. Monday through Thursday. If we have a general body meeting, we'll do that a little bit early, but go to the About Blind 75 channel and pick up the ping roll, because that way you'll just know. Like, I'll just let you know when it's happening. Usually 7 p.m., very occasionally on a Tuesday, it'll be 6 p.m. No! What do you mean the presentation left? Oh, no. Yeah, okay, wait. Hold on. Oh, no. What's going on? It's because I joined from 2 places. Okay, is it... Wait. Oh, I just made it work. This is so sad. If it breaks again, I'm gonna cry. I am gonna cry, you guys. We just got it working. We just got it working. It's fine. It's fine. Everything's fine. I shouldn't have joined from my phone. I should have just done the presentation. Oh, it's back. Okay, we're gonna go through this before it breaks again. I've got some interview tips and tricks for you guys, as well as a couple other resources for people who are newer. I don't know why I titled it this. Imagine I'm an interviewer, and I say, I want you, but it's based on these traits. So I want you guys to know interviewers are not just checking if you get the right answer. It's a little bit of like an aura loss if you're asked a LeetCode question and you just can't solve it or you don't get the optimal solution. But really the right answer part is for the online assessment. It's for the pre-screening. It's for the filtering. If you made it to a live interviewer, you're not just being assessed on whether or not you get the problem right. A big question that interviewers are trying to answer for themselves is, do I want this person on my team? Do I want this person working with me, right? Big part of that is just being likable, which is probably hard for some of you guys. Just kidding. I'm sure you guys are great. I've never met a lot of you, but I'm sure you're great. But here's some things that they are evaluating you on. They're looking for whether or not you communicate. They're looking for code cleanliness. So are you naming things in a reasonable way? Are you writing maintainable code? On that topic, modularity, which means if you've got very complex logic, are you breaking it up into pieces? When necessary, are you making objects? Are you making functions? Are you open to feedback, right? If your interviewer is giving you a suggestion or criticizing you in some way, how do you respond to it? And what I wrote as self-reflection, which means, are you looking for ways to improve your own code or your own skills? Kind of like what we did today, we started with a very naive solution and we moved forward into, I mean, in many ways, improved solutions, right? Whether they were simpler to write or whether they were of a better time complexity or a better space complexity. These are all things that your interviewer is looking for. In addition to whether or not you're like just doing good at the problem, right? So I actually can tell you about a few people who I know who have gotten internships, have gotten jobs, who have told me, hey, I actually didn't solve the problem, or maybe I didn't solve the problem optimally, but I did all these other things, right? So it's totally possible, not everywhere, but it's totally possible for you to not succeed at solving the problem, but still be moved on to the next stage or even to get an offer. Okay, so how do we approach these things, or how do we make sure that these are things that we include in our interviews? So other than just getting good at LeetCode, which is also something that we want to do, you should yap. You should over-communicate. Kind of the format that we're doing here, where I talk the whole time that I'm doing the explaining or the diagramming or the coding, is something that you want to do. We didn't do this much today because I was talking about it. In the future, I'll try and be better about this, although historically I've not been. Writing comments that explain your code. Even when we get to the more complex ones, writing pseudocode ahead of time and letting that be a guide to structuring your code is a really good strategy to use. On the topic of like feedback, listen to your interviewer. If they're suggesting something for you to do, might be a good idea to try that thing. If they suggest a data structure or a certain strategy to try, Um, be open to that. And I think finally, and this is something we'll go over more because we'll be having a mock interview event this semester. Structuring your interview time can be very helpful. So, step one obviously is to read the problem. I think it's a good idea to come up with an example that you can work through just to make sure you understand the logic or how it's supposed to work. Writing some pseudocode to think about how you want to approach the solution. Writing your actual code, analyzing it to talk about things like time complexity, space complexity, places you may have made mistakes or that you can improve things. And then actually, if you have the time, writing those improvements and saying, hey, this is how I wrote it the first time. It worked, but here's how I can do it better. So yeah. Well, that's all of our interview-based stuff, but for people who are a little bit newer to LeetCode or just newer to programming in general, I do want to share a couple of resources with you guys. So we're Leet Club, not Neat Club, but we're going to be using a lot of NeetCode's content. Specifically, the Blind 75 is from NeetCode, not LeetCode itself. But in addition to the Blind 75, NeetCode has a lot of great videos on data structures and algorithms if you're new or you just need a refresher, as well as practice problems that are specifically oriented to like understanding data structures and using them. Like we talked about, we're going to be doing these sessions in Python. So if you want to learn about Python itself, there's some great videos that NeetCode has on those that are oriented towards doing these kinds of problems. Side note, because I was trying to get a visual from NeetCode, why is their logo like low-key ugly? I remade it in like a couple minutes, and I feel like I mocked them. I feel like my version looks way better. Anyways. Yeah, so who can you do it with in terms of practicing LeetCode and stuff like that? Your friends, this club, your pets. I could go on and on about this, but the best indicator for success in technical interviews is just practice. Have you done it before? Are you comfortable with the format? Are you comfortable with your structure on how you respond to a problem? So anytime you get the chance, with anybody you get the chance to, I would highly recommend actually trying to do the technical interview format so that you're not dry running it or cold running it when you get to your first technical interview. And that's all I got for you guys. Yeah, so again, sorry we went a couple minutes over technical difficulties, etc., but we'll get back to it tomorrow. And yeah, that's it. Questions? What? Okay, I'm getting back to chat. Let's see. Oh no, guys, was the presentation not... You know what? I'm gonna just assume that the presentation was working the whole time. No, does it really look like that for you guys? I'm gonna cry. We'll share the presentation. We'll share the presentation in chat. Ah, okay, it's fine. Great. Any quactions? Okay, we're gonna go ahead and I might wear a wig someday to answer that question. What if I can't solve the problem? Do I just leave the call? My audio got better? Okay, sorry. What if I can't solve the problem? Do I just leave the call? No! Like I was saying, your interviewer is looking for so many other things. Even, like, part of this is your interviewer ideally is there to help you, right? To guide you, to figure out how you tackle problems and how you handle difficult situations. So don't leave the call. Your interviewer, ideally, if they feel like you're really stuck, will give you a small hint of some sort. Yeah, talk about your approach. This is something I will probably say a ton throughout the semester, but a solution is better than no solution. Even if you're writing a naive solution that just gets it done, but very slowly, that's a great place to start from, and then you can improve it, right? There's more questions. Leadathon when? I don't know. We've thought about that. I don't know if we're going to do that. Should we be honest if you don't know how to do it? I don't know that you have to directly be like, I'm stuck. I have no idea what to do. You can, if you're stuck on a particular part, I think a good way to approach that is, hey, I'm kind of stuck on how to handle this part of the problem. do you have any thoughts or suggestions on how I can handle that? Just so you're not saying I just am lost, right? Having like a specific thing to ask can be really helpful, both in an interview and just like in life in general. So, okay, it is it is 9:41 a.m. according to my iPad. So I think we're gonna call it there. But by all means, now that we've gone through the problem, you got a free solution. If you want to post it in one of the problem threads, nobody will judge you for having the same solution as somebody else, and you can submit it as a raffle entry for that keyboard. So feel free to do that. If anybody has questions on where to find that, let us know, but we'll call it there.